This is the radio controlled vehicle that I built. I'm just going to go over some of the basic parts. There's two battery holders here. I soldered them in series with each other, so 6 AA's, there's a total of 9 volts here. There's a power switch here that controls whether or not the power is going to the motor driver. This is an L298N motor driver, and it is controlled by this Arduino Uno. The Arduino Uno has a separate power source, this 9-volt battery right here, and I had to add this on later. I originally had the Uno powered also by these 9 volts, but every time this motor driver was driven to max power for these 4 motors, it caused a power surge that caused the Arduino Uno to brown out and fall below the threshold voltage. So I just decided the easiest fix was to add another power source. We also have this array of LEDs over here, as well as the transceiver. So each of these colors, the 5 different colors of LEDs, they are in parallel with each other, and there's some resistors going down to ground to make sure they don't burn out. This transceiver right here is an NRF 24L01, and this gets input from the remote. So the only inputs going into the Arduino are from this transceiver. Everything else is an output. I also have a speaker here that can play some songs that's evident on my vehicle Arduino code, so you can look at that further. I might do some more with this in the future. So let's take a look at the bottom. So the bottom of this vehicle, I have super glued 4 of these different DC motors with their wheels onto the bottom. I soldered the wires on each of them and drilled holes into this wood base so that I could run the wires through them. So this is the remote for my radio controlled vehicle. There are 7 push buttons here at the bottom going into these 4 mini breadboards. Each of the push buttons has a red power wire, a black ground wire, and one of these pull down resistors going down to ground. They also have a wire that's going into the Arduino Nano that is being read as either a 1 or a 0 for input. So if you're not pressing it, it's being read as a 0. If you do press it, it'll close the circuit and be read as a 1. There are also some outputs coming out of the Arduino Nano. These LEDs over here, so there's a yellow, 2 red, and 3 blue. Each of the colors is in parallel with each other, and one set will light up depending on whatever speed mode that the vehicle is in. And I'll go over that more in the code part of this video. These also have pull-down resistors over here. The other output is obviously the other radio transceiver. So this is another NRF 24L01. This is acting as the transmitter, whereas the vehicle is acting like the receiver. There are, if I turn this, there are 2 different 22 microfarad capacitors. The vehicle also has them, and that's just to filter out any noise that may happen. So this is the bottom of the remote. There's a battery holder here with 4 AA's, so 6 volts. There's also a power switch here that'll control whether or not the Arduino Nano has power. I fed the wire through these holes that I drilled in to the bottom of this wooden piece through the breadboards, and these wires go and power the Arduino Nano. I'm gonna go over the button functionalities of the remote. So these 2 buttons here control the left side of the vehicle. This causes the 2 left motors to go forward, whereas this one causes the 2 left to go back. Similar over here, these are the right side of the vehicle. If you press this, the 2 right motors will go forward, and then here the 2 right motors will go back. This button here will toggle between the different speed states of the vehicle, so whether it's in slow, fast, or turbo mode, and that will cause these LEDs to switch in between certain states. It will also correspond to the amount of LEDs that are lit on the vehicle itself. And these LEDs on the vehicle are controlled by this button here, so it can toggle them on and off. This button down here is for the speaker. I haven't given this much functionality yet other than being able to play a few songs. So I'm going to go over the remote first. This code was loaded onto the Arduino Nano. So these first few lines initialize the radio library. These next few are the button pin numbers. These are the LED pin numbers corresponding to whatever state the vehicle is in speed-wise. This will initialize the radio, the address, the actual code byte that's being sent, various button states. There's multiple for the speed because it is toggling between 3 different states and it had to be debounced. So in the void setup function, then we have the buttons set to inputs and we have the 3 LEDs set to outputs. We also have the set of lines that initialize the radio, frequency, address. The remote will stop listening because it is transmitting, and then we'll delay for a bit to make sure this setup has happened properly. In this loop function, we will read the state of the variables every time. Then we will write each of the states into 1 byte, and then we will send this byte to the receiver. This code will handle the specific speed state and will turn the LEDs on or off corresponding to the speed state. So there's a set of code that uses millis, which is the time since the program is run, and this code basically toggles between the 3 different states. It'll increment it if it's 0 or 1, or it'll set it back to 0 if it's 2. And then it will turn either the yellow, 2 red, or 3 blue LEDs on, depending on which speed state it's in. Then we will delay again at the end before we send the next transmission to the receiver. So this file on the left controls the vehicle or receiver. It's very similar to the remote in the beginning. So we're setting up the radio libraries, then we are setting various pin names. So we have the 5 LEDs right here, which are those array of LEDs on the front of the vehicle. And then there's 6 pins here corresponding to the motor driver. The enable A and enable B will allow us to set the speed of the different motors, and different settings of these of either being 0 or 1 will allow us to go in forward or reverse mode or shut off. So a lot of these lines are related to the pitches.h file, which is related to the speaker. It allows me to play certain songs. So I'm just going to skip over this part of the code. So again, this is very similar to the remote file on the right here. We have the radio being set up, the address, the byte that's being sent over. These 2 Boolean values will determine whether motor A or B are on, and it'll set this certain speed depending on whether or not it's on. We have the different button states that are being read. We also have the LED state that is being read, speed state, sound state, so this controls the speaker. These also had to be debounced so that it could toggle between different states. So in the setup function, we're setting all of these as outputs, the LEDs and the pins corresponding to the motor driver. And we will initially write all of the motor driver settings low so that it is in the off state. And this is just to confirm that it's not running after this function runs. Similar to the remote code, we are setting up the radio, frequency, address, and we are start listening instead of stop listening because this is the receiver. I have a sound that plays on in the beginning that you can hear in the video. This just notifies me that the program has started up and the vehicle is working properly. So that's one of the functionalities of the speaker. So in the void loop function, where it is constantly checking if data is being sent, so if the radio is available, it will read it. It will read it into specific bytes corresponding to how I wrote the bytes in the remote mode. So it'll read the certain states. Depending on various combinations of buttons that are being pressed, the motors will be either turned on or off. So in the forward state, meeting these conditions, both motors are set forward, and motor A and motor B are set on. So in these states, I'm not going to go through all of them, is basically the reverse. So both back buttons are being pressed, the vehicle will move in reverse. Then we have just rotate right in place, rotate left in place, right turn, back up right, left turn, back up left, and it will default with an else statement if none of the buttons are being pressed or if one of these conditions isn't being met, it will just stay in place, and as you can see here, both motors will be turning off. You can also have like various combinations, like a 1 and a 0 or a 0 and 1, and that will cause the vehicle to have certain movements. So this part of the function or the code will capture the speed state. So it will toggle between the 3 different speed states. Again, this is just debouncing. If it's a speed state is 0, which is corresponding to slow, it will write 150, which is on a 0 to 255 scale. So this sets it at about like a middle power. Anything below this value, I notice the vehicle doesn't move, so this is kind of the threshold value. If it's in fast mode, I'll set it to 200, and if it's in turbo, I will do max power. Otherwise, I will turn it off. And this is, again, a check statement. It'll turn it off. Exact same thing for motor B this time. So it depends on whether or not it's on, and it'll set the various speed. The LEDs are also debounced. So if the speed state is 0, it will just do 2 of the LEDs that will turn on, which you can see in the video. If it's in fast state, it'll turn on all of them except the white ones. And if it's in turbo mode, all the lights will turn on. Otherwise, they'll all be off if the LED button is not toggled. The sound will play certain sound functions. I'm just going to skip through this. This will just play different notes, songs that I'm still working on. Eventually, at some point, I want to have some form of voice recognition and turn this from a radio-controlled vehicle into a robot. So these are some pictures I took along the way to document my development process. So the picture on the left, you can see I soldered on wires to the different DC motors on the positive and negative terminals. And the picture on the right, I'm soldering on the different switches, one of them being used by the vehicle and the other being used by the remote for the power sources. The picture on the left shows right after I finished drilling in the Arduino Uno and motor driver and battery packs into this wood piece, drilled holes through for the motor wires, and super glued on a breadboard. You can see on the right there's I've super glued on the DC motors, and I'm about to feed the wires through these holes. And then you can see I soldered the 2 battery packs together in series so that it would add up to 9 volts, and the switch on as well. Here you can see more progress being made on the vehicle. Basically all the wiring for the motor driver has been done going into the DC motors, and the batteries are already in. Here on the right, you can see on the top of the picture the various outputs coming from the Uno and going into the motor driver, and the outputs also coming from the Uno and controlling these LEDs. And there's a lot of clean wiring going into here, making sure the different colors are in parallel with each other. And here you can see the finished product. Here we have the radio transceivers on here as well, some of the capacitors. It shows it being on, the battery pack that I had to add at the end. Here we have the remote, the back of it. So I drilled in the battery holder again with a switch, fed the wires through these little mini breadboards with the buttons that I already placed in design. So here we have, none of the wiring has really been done for the buttons other than ground, but the transceiver is now being attached with the Arduino Nano as well as the LEDs. Right here I changed the configuration, as you can see, for the different speed mode. And here you can see all the wiring has been completed for the buttons, and they're now being read as inputs by the Nano, and the transceiver and LEDs are the outputs. Thanks for watching. I hope you thought the radio-controlled vehicle I built was pretty cool. Some additions I want to do for part 2 is I want to have some form of voice recognition and commands, or even some object identification with a camera so that it could look for obstacles. It would kind of turn it more from a vehicle into a robot. Uh, Here are some of the code links for the two different files. They're also in the video description. And here's some of the parts that I used in case you're curious.